Okay, question 8 on the 2018 AS paper, third mechanics question. I can do it to an hour. Okay, this confused a few people. Some people tried to use speed equals distance over time. Some people tried to use SUVAT. As soon as you got a weird equation from the displacement x, which is s, from the origin being something like half t squared minus 2t plus 1, you're well out of the realms of SUVAT. You haven't got constant acceleration anymore. Okay, you're definitely out of the realms of speed equals distance over time. Okay, so we get given that the displacement x equals half t squared brackets t squared minus 2t plus 1. Okay. A, find the times when t is instantaneously at rest. If it's instantaneously at rest, it means that the velocity is 0. Okay, not the displacement is 0. We can't put that equal to 0 and solve it. That would be quite straightforward 5-mark question. So we need velocity. So we need to know that velocity is the differential of the displacement. So it's going to be dx by dt. Okay, so to work out dx by dt, we need to expand this, so we're going to get half t to the power 4 minus t cubed plus a half t squared. So when we differentiate that, I'm going to get 4 times a half, so that's 2t cubed minus 3t squared plus t. Okay, and that's equal to 0. Okay, you can't just divide by t. So we're ignoring the fact that t could possibly be 0, which it is, because t is greater than or equal to 0. So we're allowed to have a time of 0. Okay, so we can't just divide through by t randomly unless we know that definitely t isn't 0. Okay, so how do we solve that? Well, start off by factorising out t. That's getting round the dividing by t, but we're still keeping it there. So we get 2c squared minus 3t plus 1 equals 0. Then we factorise that bracket. Okay, you've all got shiny calculators that will do that for you. Okay, but it shouldn't be too much of a leap to get 2t minus 1 and t minus 1. Okay, right, so in which case we get t equals 0 from that one, t equals a half from that one, and t equals 1 from that one. Okay, so those are 3 times for which the particle is instantaneously at rest. Okay, v is 0 at those points. Okay, b is a bit more confusing. Find the total distance travelled by p in the time interval 0 to t to 2. Okay, so I sketched a graph because I'm sad like that. Okay, I said, well, we sketch a graph of the displacement x against t, so I want to draw this graph. It's a bit confusing, okay, but I know it's got to go through the origin, because when I put there's nothing left at the end, there's no y-intercept. Okay, I know it's going to have a flattening out at t equals a half. Okay, I know it's going to have another flattening out at t equals 1. Okay, and I know it's going to have and yeah, so it's flat at t equals 0, so the displacement, the gradient is 0 there. Okay, when I get to t equals a half, 1, 2, I get to a half, it's going to be flat again. Okay, when I get to 1, it's going to be flat again. So the graph's going to look like this. Okay, we need to work out how far it's travelled in that interval. Okay, so it starts here at 0, it goes up to here, it goes back down to here again, and then it goes up to here. Okay, so the things we need to work out is how far does it go up, how far does it go back down again, and how far does it go up to there. Okay, so if we work out when t equals a half, okay, if we sub in t equals a half to this, okay, we get x equals 1 over 32. Okay, so it goes up by 1 over 32. It then goes down by 1 over 32. Okay, and then it's going to go up by subbing in what t equals 2 to get that one. So when we sub t equals 2, we get x equals 2 as well, I think. So we need to add together 1 over 32 plus 1 over 32 plus 2, which gives us 2 and 1/16, which if you turn into a decimal and round it, 2.0625. The March scheme gave answers which rounded to 2.06 metres. Okay, a lot of people got 2.03 because they didn't add on that 132 going back down again. It's not an easy question, that one, to get your head round. Show that P will never move along the negative axis. Show that it's never going to go beyond there. Well, if you look at the graph, it's accelerating that way now. It's probably never going to come back here. But how do we show it? We have to be very clear on it. We have to basically show that x will always be greater than or equal to 0. So how do we do that? Okay, we can say that t squared is greater than or equal to 0. Okay. Then we have to show that this is also greater than or equal to 0, because we've got two positive numbers times together, the answer must be positive. So, generally to show things are greater than 0, we complete the square. Okay, so t squared minus 2t plus 1, if I complete the square on that, I get t minus 1 squared. Okay, it's a perfect square, so that has to be greater than or equal to 0. Therefore, half t squared t minus 1 squared is greater than or equal to 0. X is greater than or equal to 0. Okay, it's not enough to just randomly say, yeah, that's greater than or equal to 0, let's go to it. You need a bit more explanation, breaking up into its two parts. Or saying this is a perfect square, so it must be greater than or equal to 0, or something like that. Okay, right, stay safe.